Imagine spending $327 million on building a spacecraft with over 4 years of design, months of testing, and hundreds of engineers checking every calculation. And yet, nearly after a year of flying 340 million miles towards Mars, everything goes wrong. The mistake wasn't a mechanical failure, it was a tiny mix-up that no one noticed, and it would destroy the entire mission. So, how does something like that even happen? And more importantly, how does NASA miss it? To understand it, we have to go back to the beginning. It's 1998. NASA is preparing a new mission to Mars called the Mars Climate Orbiter. Its job is simple: study Mars's atmosphere, weather patterns, dust storms, and how the climate changes over time. This matters because it helps scientists understand how Mars once had water and whether humans could ever survive there in the future. After 4 years of building the Mars Climate Orbiter, it finally goes through testing. Multiple NASA teams comb through the maths, check every system, and triple check the numbers. Everything looks fine and it's ready to launch. Or at least, that's what everyone thinks. Once it lifts off, the spacecraft begins its 347 million mile journey towards Mars. For almost a year, engineers track every move, hoping everything behaves normally, until September 23rd, 1999. The Mars Climate Orbiter is approaching Mars. This is the moment it's supposed to enter orbit. To do that safely, the spacecraft has to pass through roughly 140 kilometers above the surface. If it's too high, it flies right past the planet, too low, and Mars's atmosphere tears it apart. NASA sends the command to fire its thrusters, so it can enter Mars's atmosphere. However, as soon as the thrusters are turned on, silence. And just like that, NASA lost $327 million. So, where did it all go wrong? Well, actually, the spacecraft did exactly as it was told. The problem wasn't the spacecraft. The real problem was that multiple NASA teams assumed everyone else had caught the mistake. A mistake that came down to 2 teams speaking different languages. What do I mean by that? Well, as it turns out, one engineering team calculated thrust in imperial units, but the system reading the data assumed metric, which no one had noticed. Which means pound seconds were read as Newton seconds, so every course of correction was off by a factor of 4.45 times. Because of this error, the satellite was off course for the entire journey, so by the time Orbiter had reached Mars, it was too late. The spacecraft flew far too low. It either burned up in the atmosphere or skipped off into space, never to be seen again. Within seconds, a $327 million mission vanished.